First, the next question, number 46. A single phase 400 volts 50 Hz transformer has an iron loss of 5000 watts at the rated condition. When operated at 200 volts 25 Hz, the iron loss is 2000 watts. When operated at 416 volts 52 Hz, the value of the hysteresis loss divided by the eddy current loss is dash. So this is not a multiple choice question, and we will have to find out the answer by working it out step by step. So since we have a lot of information here, let's note it all down. The first thing we have is, let's consider this to be V1, single phase 400 volts. So this is V1, 400 volts, F1 is 50 Hz, and we have the iron loss, let's write that as PI1, 5000 watts. When operated at 200 volts, let's call this as V2, 200 volts, F2 is 25 Hz, and PI2 is 2000 watts. Now the final case is given to us as V3, 416 volts, F3 is 52 Hz, and we need to find out the ratio of hysteresis loss to eddy current loss. So that would be PH divided by PE. This is what we need to find. Now if you notice, we have different values of frequency and different values of voltage. So for a transformer, you need to know that the ratio of V by F must be constant for the different cases. So let's check that. Now V1 by F1 is 400 divided by 50, which comes to 8. V2 by F2 is 200 divided by 25, which is also 8. So you see the ratio is constant. Now if we check for V3 divided by F3, the ratio is 416 by 52, which also comes to 8. So when all our values are the same, we can take the relationship between the losses and the frequency into consideration. Okay, so in general, iron loss is the sum of hysteresis loss and eddy current loss. Okay, so iron loss is the sum of the two, both hysteresis and eddy current loss. Other relations are, the hysteresis loss is directly proportional to frequency. So we can write this as PH is equal to A into F. We can remove the proportionality symbol and write it as a constant A. Similarly, for eddy current, the eddy current loss is directly proportional to the square of the frequency. So let's write this as PE equals to B into F square. So this is important. Once you find out that the ratio of V by F is constant, we can take the relationship of the losses with the frequency. So hysteresis loss is directly proportional to the frequency, while eddy current loss is proportional to the square of the frequency. So here we have two relations, PH is equal to AF and PE is equal to BF square. Now let me just grab another sheet of paper and we'll continue here. Alright, so we have two parts now. We have two different cases to calculate for. The first case, we have PI1 is given to us as 5000 and PI2 is given to us as 2000. So let's write two different equations for this. PH1 plus PE1, and the second one is PI2 is equal to PH2 plus PE2. So we have two different equations. The sum of the hysteresis and eddy current is equal to the current loss, copper loss, iron loss. Hysteresis plus eddy current equals to the iron loss. So let's substitute the values here. We have 5000 equals A into 50 plus B into 50 square. That's because PH and PE are AF and BF square. So we have the frequency of the first case given to us as 50 Hertz. So we can substitute that over here. Now we get 5000 is equal to 50A plus 2500B. Similarly, for the second equation, we write this as 2000 is equal to A into 25 plus B into 25 square. And this would give us 2000 is equal to 25A plus 625B. So we have two equations with two unknowns A and B. By solving both of them, we'll get the values of A and B. So the value of A is 60 and the value of B is 0.8. You can solve it and check the values. A is 60 and B is 0.8. Now because our ratios are the same, V by F ratios are the same, the values of A and B are also constant. Now these are constant. So the ratio of PH by PE will also be the same. Now PH is AF divided by BF square. So let's substitute. We get 60 times. Now what is the frequency of the case that we are supposed to find? 52 Hertz. So this is 52 divided by 0.8 into 52 square. Solving this, we get 1.4423. So this is the final answer. The ratio of PH by PE is 1.44. So we can enter that here, 1.44. I hope this has helped.